and you have all of those functions in the module available to you. If you don't import the module, you don't have access to the function. We'll see how to do that today. But you also have what are known as libraries. And that's similar to R. Libraries are much more extensive. A library will have its own folder on a Windows machine and will have bunches and bunches of not only functions, but data sets and documentation, all kinds of things. So, and those are, you can think of modules as just kind of extended functions, and you can think of libraries as extended modules, right? So Python gets a lot of horsepower from functions, from being a functional language. Here's the basic syntax for defining a function. You use the def keyword, and you make up a name for your function, and the name should reflect what it does. You can call it anything you want as long as you don't use a reserved word, but it should say what it does. And then you can have optional arguments. The brackets, of course, the brackets mean it's optional. So most functions do have arguments. And then you have one or a series of statements in the body of the function. Okay, so there are at least 5 different parts to this. You have the def keyword, that's one necessary part. Function name, one definite necessary part. You've got to have these parentheses, otherwise it won't recognize it as a function. That's a necessary part. Arguments are not necessary, but they're very handy. And then statements. So you have at least 5 working parts here, minus this one, I guess, which is the optional arguments. Notice the indentation again. This, of course, is, you're probably used to this by now. The indentation at the end of the function, the indentation stops. And so let's look at a couple of these. Right here is we're defining a function. Doesn't have any arguments, this function. We're just saying the function name is print welcome. No arguments in there. Oh, you got to have the colon too. I always forget to say that, but you need, anytime you're establishing a block of statements like this, you've got to precede it. First non-indented line's got to have a colon at the end of it. So this function, I'm sure you can figure it out, just simply prints this out, prints welcome to the future value calculator. But let's see. Yeah, so if I run this, nothing happens. And well, why is that? Well, all I did was define it, and it's sitting around in memory, right? It's in my session. When I say memory, in this case, I mean random access memory. You can think of your session as like I like to call it an electronic bucket, and it partitions off part of your active RAM, and you can create different parts, different what's it called, workspaces. You can establish different workspaces, which are just like different electronic buckets that have different names. The one on top is the global workspace. It doesn't have its own special name, it's just global. So as I'm building objects, variables, functions, they all get tossed into this top level workspace, which is the global one. But so where did our function go? Well, you got to call it for it to do anything, right? And the way you call it, of course, is you type the name in, and no arguments, but you got to have the parentheses, and it just prints out welcome to the future calculator, because that was in the body of the function, and it prints out an extra line. Well, what happens if you do this? What happens if you say, I forget to put in the parentheses, right? So I just say print welcome like this, and I do this all the time. It shows you the definition, the byte, I think it's called the bytecode definition. It just tells you that there is a function called this, and it's at this location, whatever that means. Is this hex? I don't know what it is, but it's some sort of address, right? So that's what that does. Now you have to call it. So that's the point I'm trying to make. You have to call a function. Now that's really simple. So here's another one, and this is a little different, I guess. Let's this is here where, and I like the way he does this. Muroc, he throws things at you, starts with the very most basic case, very simple, and just kind of torques it up very slowly. So we have an argument here. So instead of hardwiring the message in the function itself, we can pass a variable called message to it, like this. Okay, and so when we run this one, it's a little different. But when I run this, it well, first of all, it'll define. You'll get a variable. The string, welcome to the future value calculator, will be a string, be stored here. Then I'll define the function using message as the argument, and then I'll call it all at the same time. So this will just do the same thing, but it's going to call it, and so it'll run when I do that, right? Welcome to the future value calculator. So here we have one argument, and the message is printed. So that's pretty simple. Okay, well, here's one that has two arguments and returns a value, right? So, and on this slide, and I think the script is faithful to it, but I'm not sure. What does this demonstrate that we haven't seen before? Well, there's two arguments in the body of the function. It plays around, calculates stuff with these two arguments. So we get MPG, and then in the second line, it rounds MPG to 1 decimal point. And again, you could put that all on one line, and you should actually. Notice the return keyword. The return keyword does not have to be at the end. What the return keyword does, when it encounters return, it exits the function. And whatever the value is on that line, that's what the function returns. Okay. Why would you want to have a return keyword that's not at the bottom? Well, maybe, you might have some if statements in here, some control statements, depending on what the value of the variables are. You might not want to, sometimes you might want to go all the way to the bottom of the body. This is the body. Sometimes you might not, depending on what it is. So you could have multiple returns that are on different lines that don't both execute, but one will execute in some situations and the other in the other situation. Okay, another thing about Python, if you're an R user like I am, in R, user-defined functions can only return one thing. And you might say to yourself, what? How can that be useful? Well, one thing can be a list, and a list in R it's a data structure that can be as large as you want it to. A list can have any number of components, and each component can contain all kinds of calculations. If you use R and you do any simple multivariate stuff like regression, and you go and look at the object that gets created, it's this humongous list. It's got all of these numbers in. Okay, well, Python's not like that. Python, you can return more than one thing. You can return 2 things, 3 things, 4 things. So it's a little more versatile in that way. On this slide 6, it just defines it. So I would have to call it, but if I carefully put these in there, and sometimes when you copy off a slide, you get weird little characters. I don't see any. It will define the function. It will instantiate a value for miles. It will instantiate a value for gallons, and then it will call, right? What the function does, it returns MPG. It will call the function, and it will assign the value returned, which is this calculated value, to this. Okay, but notice a couple of things. So it should work just fine. So let's try it. And I'm going to have to save it because I made some changes, but that's okay. And let's see, we got miles per gallon equals, okay, well, so what happened there? Well, I think I can explain that. It printed, it called it, and should be miles. Yeah, oh, I know. Go back. It returned MPG, right? So if in MPG, I didn't say print MPG, I said 37.5. Why do we have this? We have this because the way the script was originally set up by me, these lines weren't here. So in this case, oh, that's not going to work. What it's doing here, it's just the function is simply, it's printing out this string, and this is meant to keep it from throwing a line. But if I want to see MPG, I have to, it returns MPG right here. And so I could call it and say, show me MPG. And okay, let me show you something else. Even though the names, right, here are the names of the argument driven, that's not the same as this. This is miles. And the name of this argument is gallons. That is the same. But when I call the function, these are the named defined arguments in the definition of the function. But I can call the function and I can name my arguments anything I want, as long as they're in the same order, right? So I can pass miles 500, I'm passing 500 into this function. So this gets instantiated to 500, and gallons is the same. So the point is that the calling arguments do not have to be the same name as the named arguments in the definition of the function. They can be, and if they are, you can have these in any order you want if you have the exact same names. So that's what this is meant to show. And let's run it again, and hopefully everything will work. We get miles per gallon, but if we want to see it, we have to say, well, what is MPG? And it's 35.7. Okay, so the contribution of this slide is you can have more than one argument. You can call the function with different named arguments. Okay, so far we've just been playing around with individual functions, right? Well, if you want to build a program, even if it's a short program, a couple of pages long, you might have several functions in your program, but you want to control the order in which they get executed. And that's what main does. Main, I don't think, yeah, I guess main is a reserved word. You want to define a main function that usually goes at the bottom of your program that calls everything else. Okay, so in this example, and is this slide 8? It sure is. Let me call this up. So we're introducing the use of main, and we'll show you how to call main in just a second. Again, this is in scripts. This is slide 8.